Okay, the next. Okay, the next topic that I'm going to talk about, that is the while repetition statement. If you want to do or to perform the iteration, you need a repetition structure. Programmer will specify an action to be repeated while some condition remains true, right? And then you can use this while statement. In pseudocode, you can use while, right? Why? Why there are more items on my shopping list? Purchase next item and cross it off my list. Okay, why there are more items to be shopped, right? On my shopping list, you can continue shopping. This is an example of how to use while, right, in the pseudocode. While loop repeated until condition becomes false. Right? So this way, there are more items on my list. If it's still true, you have to purchase more items. What is the statement that can make this statement to be false? Anyone can help me? There are more items on my shopping list. If it is true, so we'll continue doing this sentence. How to write or how to make it false? Anyone can help me? Can answer this question? What is a statement to make this expression to be false?
Using if else.
No, not using this if else. This is a conditional statement, okay? This is a conditional statement. How to make this conditional statement to be false?
If there's only one item, it will be false.
Until there are no products in the list. Correct, Mahita, Meta, Suhani, sorry. Okay, until there are no products in the list. Correct. There are no items on the list. There are no items on the list. Okay, this could be false if you can find the condition that there are no items on the list. So it will make this statement to be false. Okay, so you can see the example that is the C programming. So before you can use this variable, you need to initialize it. Integer means integer, okay? Product is an integer and it is initialized. Initialized to be true. While product is less than 100. Oh, sorry, 1000. Now product is true, right? So what does this statement do? What does this statement do? Product is assigned by 2 multiplied by product. Times product by 2 until 1000. That's right. Thank you, Pong Panot. Okay, so this while loop will perform starting from product is equal to 2, and then 2 multiplied by 2, and assign 2 multiplied by 2 is 4, and then assign into product. So product will be 2 by 2 is 4, and then 4 multiplied by 2 is 8, and then 8 multiplied by 2 is 16, and so on, right? So on until it's greater than 100 or 1000. Okay, what is the last? Okay, this is maybe harder question. What will be the last value of the product in this case? Okay, correct. 1024. Okay, good. Okay, you can read this, and I will not talk about that today. So if you want to write, if you want to draw a flowchart for while repetition statement, so you can also use diamond to check for the condition, right? From the previous example, right? If product is less than or equal to 1000, if it's still true, so you multiply 2 to the product and then assign it back to product, and then you, because it is a while repetition statement, it will go to check the condition again, right? If it's still true, so you can do this loop many times until you have got the product to be 1024. 1024 is not less than or equal to 1000, so it's false, and then we'll go out of the loop. Okay, so we can write while loop in terms of the conditional statement or the diamond. We call this diamond. Okay, this is a if clause as well. Have a question. Can I use shorthand operator in flowchart? What does it mean by shorthand operator? Shorthand operator, what does that mean? Shorthand operator. Right. I think you shouldn't. The reason is that these kinds of operator, shorthand or the shorthand operator like this will be used only in C language, C++, C#, and Java. For other programming languages, we are not going to use these kinds of operator or shorthand operator. So you have to be careful that someone or other programmers cannot understand what you are trying to represent. So I suggest you not to use this shorthand operator. Thank you for your question, Pongpanot. Pongpanot asked me that can we use, right, product asterisk sign equal and true. This called as risk. Asterisk is star sign. Okay, what does this mean? This is equal to product assigned by product multiplied by 2. This is a short form of this one. This one is semicolon. Okay, I suggest not to use this in flowchart because someone may not understand what you are trying to represent. Okay, so in order to make sure that everyone will understand what you are writing, so please use the common notation. Okay, the next one that I'm going to talk is the counter control repetition. From the previous slide, we used while loop, right? But we don't know how many loops that we are going to perform. So for the counter control repetition, you can guarantee or you can know in advance that how many loops that you are going to have, or at least you can guess the number of the loop. So loop repeated until counter reaches a certain value. Suppose you want to have a loop, 10 loops, right? You can just use for loop for I from 1 to 10. So you can guarantee that the number of the counter or the loops will go to 10. So we have the definite. Definite is opposite to infinite. Definite means you can define the number of the repetition, right? So for example, a class of 10 students took a quiz. Then you want to know the class average. So you will know in advance that the number of the students will be 10. So you will have to write a program in order to calculate or to get the number of the score, 10 scores. So this my meanings. Okay. So okay. So this one is a good pseudocode or algorithm that you can use to collect the number 10 numbers, right? You have to start from the set total to 0, and then get counter to 1. While get counter is less than or equal to 10, then input the next grade. Add grade to the total, and then add 1 to the grade counter, and then do this while loop for 10 times, right? You can guarantee that you will perform this 10 times, right? Because you add 1 to grade counter. Then after we finish 10 times of this loop, so we can go out to the line 9. Set the class average to the total divided by 10. Total divided by 10, right? This is the grade average. Maybe you can use the average here. Average is equal to total divided by 10, and then print class average. This is an example of the pseudocode for finding the grade average for 10 students. Okay, and then we can write the C program like this. Maybe you can try to type this in the lab, right? In order to check whether you can print out the grade average for 10%. Okay, so but from this program, right, if you could remember, the first 2 lines are comments, right? We want to write program to use the counter control repetition, and the third one is what is the library standard input.h, right? Is a header file. And then in this program, you have only one function, which is a main function, right? Return integer. And then this is how you can define variables, right, into integer, right? Integer type. So we have 4 integers. The counter. So we are going to concentrate on the counter control repetition. Counter is a number of the grade to be entered next. counter to control while loop. Right? We want to use counter to control while loop. And then counter has to be initialized to 1. Right? Initialize counter to 1. Don't forget, if it is the control variable, you need, first of all, don't forget to initialize it, initialize phase. Okay, this one is a good example. C program. In main program, you will have the first part, that is the declaration part, where you will use to declare variables. And the second part will be initialization part or initialization phase. Right? You need to initialize all possible all variables that you need to initialize. For example, if you want to sum the grade into the total, you need to initialize total to 0. And counter, you need to set to 1 because you want to sum up to 10. Okay, this while loop will be executed 10 times. So you set counter less than or equal to 10. While loop will iterate as long as counter less than or equal to 10. In this way, counter or this loop will execute 10 times. And the last one, counter is equal to counter plus 1. So this is increment the counter by 1. Okay. And then when you finish all the previous process, right, you can come up with the total. Total will sum grade, 10 grade, the 10 grades of 10 students into the variable total. And then you need to find the average here. So what you have to do is you can just simply, this is the termination phrase, that is average is equal to total divided by 10. This is the integer in division. So you can calculate for the grade average and then you print out average for the class of 10 students. So from this example, if you run, and if you write this program correctly, when you run it, execute it, you can get, you have to input 10 numbers, right? You can input 10 numbers and then it will print out the class average, that is 81. Okay, please try to type this program in the lab in the afternoon. If a counter or total is not initialized, the result of the program may be not correct. Okay, there is an example of logic error. Even it is not compilation error, but if you didn't initialize it before, it can cause the incorrect output. Because when you didn't initialize this before, maybe in the total, in the main memory, right, when you allocate total or counter in your program, right, maybe it will allocate in the main memory, and you can get the garbage value from the main memory. So the program can cause syntax error or sometimes the incorrect output. Okay, so the counter and total need to be initialized. So you need to initialize all counters and totals. Okay, the next step is the formulating algorithm with top-down stepwise refinement repetition. So sometimes when you want to solve the problem, if you have a computing problem, right? Sometimes you need to think of it as a top-down refinement process, right? You have to think from the top and then you subdivide it into the smaller part. So the problem will develop a class averaging program that is processed at a arbitrary number of grades each time. If you don't know the number of students, right? It could be changed, right? If I teach you this course, then maybe the number of the students in this course is 79. If I go to another course, right, the student may be 80. So you have unknown number of the students. So how can we do, right? So that's why we have to use the sentinel value. Sentinel value, what does it mean? Sometimes you need the signal value, or we can call dummy value. Do you know dummy, right? Or the flag value. Dummy means the value that is not possible to be an appropriate value. For example, for the grade or for the score in the class, like -1 could be used in this one because no one can get -1 value and -1 score. Okay, so we can use -1 to be the sentinel value in order to make it to be the last number that will be the end of inputting, right? I can show you the program. We don't know the program. We don't have the program. Okay, for the top-down step, my refinement, maybe we have to begin with the pseudo co-representation of the top by determining the class average for the quiz, and then divide top into the smaller tasks and then list them in order by starting from initialized variable, input sum and count the quiz grade, and then calculate and print the class average, right? So we can subdivide into 3 phases, right? Initialize, processing, and then terminate, and then print out the final result. Okay, that is we call the top-down refinement, top-down step-wise refinements repetition, right? Now we have what I'm going to say is that suppose we have a complex problem. What we have to do is you have to subdivide or refine your problem into the top-down step-wise refinement. And all program, I could say that it can start from these 3 phases, right? Initialization, processing, and then termination. Termination, sometimes we can call it the output, right? To calculate and to print the output. And processing can be the process that we can input the data correctly. Okay. In software engineering, each refinement as well as the top itself is a complete specification of the algorithm. Only the level of detail varies. Okay, as I just told you that any program can be subdivided into 3 phases like this: initialize, process, and termination. Sometimes we can call input, process, output, or whatever, right? The initialization could be in the input phase. That's all. But for any program or in software engineering, it can be the same specification as I just told you, but it can be vary in the detail, right? Or for this example, the initialization process will be initialize total into 0, initialize counter to 0, and then the next one is processing. Processing will start from input the first gate and then do while loop, right? While loop, then add the grade into the total, add 1 to grade, counter, and then try to input the next grade, and then so on until you get the sentinel value. Okay, you can see that from this algorithm, right? Instead of using the counter, you can use sentinel control. Why the user has not yet entered the sentinel? For this example, we can use -1, right? Enter the sentinel. If the first gate or the first score is maybe a full score 100, it's not the sentinel, so it will add to total, set count, or add increment counter, and then get the next grade. Right? If it's not sentinel, so it will perform this loop until you can get the sentinel. Okay. And the last one is to calculate and print the class average. That's always the same. But in order to check for the correctness of the program, you may have to check whether the counter is not equal to 0. Right? If the first gate entered is -1, you can see that counter is equal to 0. Right? So if the counter is 0, when you calculate total divided by counter, right? If counter is 0, it can cause what we call divide by 0. This is an error, divide by 0. You have to avoid this situation. When you divide something by 0, it can cause program execution error, or sometimes it will be the program termination. That's what we not want it to be occurred. So if you want to be a good programmer, if you know that you will need to use divide operator. When you use divide operator, one important thing that you have to keep in mind is that you cannot divide 10 by 0. It can cause divide by 0, right? So if you want to be a good programmer, you need to check for the counter. If the counter is not equal to 0, okay, you can find the grade average. Otherwise, you print no grades were entered. We use these else statements in order to make sure that the divide by 0 error will not be occurred. What will happen if during the execution, what will happen if you execute to the part that divide by 0? The program will collapse. The program will be stopped and go to the abnormal program termination. Abnormal program termination. This will be shown for the Windows, right? And for the Unix or Ubuntu, right? It will show the abnormal program termination. Memory for dump or something. What's happened? I cannot clear this one. I cannot write. I don't know why. What's happened? I cannot delete. Maybe I have to log out and then I will come. Okay, now we go to the program, right? To use Sentinel control repetition, right? You can see that. Okay, now you have to define the float. Float is the real number, right? For the average, right? We define average as a floating point, right? And then right, okay, you are going to use a Sentinel value right here, right? You can set grade is not equal to get is not equal to 1, right? So while loop here repeats until the user enters a value of 1. So we can call this -1 is a sentinel value. It means that the value if you input, you will stop this loop. And then counter, if counter is not equal to 0, right? You can calculate for the average. And then you can print out this. Because it is a floating point, right? You have to use the percent sign F in order to print. You can see this percent sign F, right? Is the if you want to print the real number. Dot 2 is a decimal, right? If you have the value 100 and okay, because it is get average, right? It's not could be greater than 10 or 100. So suppose you can get the get average as 81.78.2, right? So if you write the format like this, it will show only 81.72. The number 2 means the number of digits right after the point here. The number of digits after the point. Okay? So this is a way percent sign dot 2f, right? If you want to print the floating point number or the real number. And then this is an example of inputting until right you input -1 and the loop will be stopped, and then the grade the class average grade will be print out. Okay, this is an example of how to use Sentinel control repetition instead of to use the counter control repetition. Okay. So good programming practice in a Sentinel control loop, the prompt requesting data entry should explicitly remind the user what the Sentinel value is. For this example, right, the prompt means here, right? It will show all the time that enter -1 to n, right? So program can be easily know that if the user want to end up in this program, just type -1. Okay, this is good programming practice. Using precision in a conversion specification in the format control string of scanf statement is wrong. Precision are used only in the printf conversion. Okay, percent sign %f, percent sign %s cannot be used in the string scanf format. Okay, or the scanf format, you are only using printf format. Okay, using floating point number in a manner that assume that they are represented precisely can lead to incorrect result. Floating point numbers are represented only approximately by most computers. Okay, floating point, you will have to keep it as an approximate number. It's not the exact number of that floating point that you think of it. I will tell you this again later in the IEEE 754 format. Do not compare floating point values for quality. Okay, that's why the floating point cannot compare. And the last topic today is about nested control structure, right? Suppose we have a problem. A college has a list of test results, 1 equal to pass, 2 equal to fail for 10 students. So the problem is to write a program to analyze the result. If more than 8 students pass, print restitution for 10 students. So we can notice that the program must process 10 test results, so we have 10 loops. So counter control loop will be used for sure, right? Because you know the number of the counter. So 2 counters can be used because the first one we will count until 10, and second one we have to count to 8. Because if more than 8 students pass, right, we have to check for to print out the restitution. It's nonsense. No? So one for number of pass, oh sorry, for 2 counter will be used, we have to count for the number of the people pass and the number of the people fails, right? And each number could be either 1 or 7, like the test result. If what happens if the number is not 1? We assume that it is a 2, right? So this is the nested control structure. So we can, okay, this is the way that we are going to solve the problem. So first of all, you have to go to the top level outline, right? First of all, you have to analyze exam result and decide if the tuition should be raised or not. Okay, and then for the first refinement, initialize variable, and then input 10 quiz gate, and then count pass and fails, and then print a summary of the exam, right? Decide if tuition should be raised or not. Okay, for the refine initialize variable, you have to initialize pass to 0, set pass to 0, and failure to 0, and the number of the student counter set to 1. This is the initialize phase. And then for the refine, for the input, right, you have to use while loop, right? While the student counter is less than 10, then input blah blah blah. If the student pass, add 1 to pass. If the student not pass, so add 1 to failure, right? This is the what we call the pseudocode that we are going to write, and then add 1 to the student counter, right? This is input process. And then the next one is the output process. So you print a summary of the exam result, print the number of passes, print the number of failures, and then if more than 8 students pass, then print out restitution. So we can subdivide or decompose the problem into the smaller part, right? As you can see that every program, if you start from initialization, input process, process, and then print out the result, that is output process. That's all. This is a computing program. The computer, this is a computing program, right, that you are going to write. This is as always, right? So after you get the pseudocode, you can write it in, if you get that pseudocode, you can write it in terms of the algorithm, right? In your algorithm, you can see initialize pass, and then input, and then print out the output like this. And then you can convert this into the C program, right? According to the previous pseudocode. You can see this one is a, yeah. if statements are nested inside the while loop. In this topic, right, I'm going to show you the nested loop or nested loop, right? You can see that in while loop, right? We also have the nested, that is the inside while loop, we have the if clause, right? That is a nested while loop, right? While loop until 10 student has been processed. Okay. And then this one is a part of the termination phase. That is to print out the result, the number of the pass, the number of the failure. And then if pass is greater than 8, it will rest tuition fee. For this example, you can see that you can input, right, 1, 2, 1, 2, 1, 2, 10 times. And then you can see that pass rate is 6 and fail rate is 4. So restitution will not be printed out. But otherwise, if the pass rate is more than 8, 9, or 10, right, the restitution will be print out. So this is the way that our problem of the how to print out the restitution or not problem will be execution. Okay, this is an example of the pass rate is 9, so I can get restitution print out on the screen. Okay, that's all for today. Sorry for, okay, it's 10:30 already. You have to go to calculus class. Sorry for making you late, right? Okay, I have some problem with my iPad. So thank you for your attention. I would like to stop here. If you have question, you can ask me later in the afternoon class.